Today, we'll be reviewing exploratory data analysis, and in our wiki, you will find there are two links. One is the exploratory data analysis, and there's another link which is called low-code exploratory data analysis, and I'm going to try to mix both. The exploratory data analysis just refers of trying to get a feeling of what type of data and how they are distributed of one of your data sets when you are trying to find out or extract information. And we can use all the different visualization libraries like Matplotlib and Pandas and Seaborn to extract information from our data set. And also, of course, we need to be using Pandas for reading the data and cleaning the data or selecting specific types of data. And then once we have done that, then we can start using the different visualization libraries or basic Pandas functions to extract the basic information. So let's begin with the exploratory data analysis section. And if you have any questions, please open your microphone and ask questions or put it in the chat. Okay, so whenever we get a new data set, the first thing we always want to do is just do an exploratory data analysis. Maybe our data needs to be cleaned, or maybe the data is raw, so we have to transform it or pre-process it. And then once we have the basic information about what type of behavior we see in our data or some patterns that we detect, then we can try to create models in order to have like predictions or something. Okay. So what is the exploratory data analysis referred to? So this is a common term. It was defined by John Tukey back in '77. And the idea is that once you have a data set, you don't need to know what type of distribution your data set obeys, but you can extract some basic information and Tukey define this 5-number summary of your numerical data. And at least you should know what is the maximum, the minimum, what is the median, and where are the quartiles defined. And with that type of data, then you can do define like a new quantity, which is the interquartile range, which is the difference between the third quartile and the first one. And whatever lies like 1.5 minus 1.5 times this interquartile range below the first quartile, then this will be an outlier, and everything that lies above the third quartile plus 1.5 times the interquartile range will be an outlier. So this is the criteria from Tukey to define an outliers. There's some other definitions or methods to detect outliers, and one of them is when you have a normal distribution, then you can say that whatever lies above 3 sigma or standard deviation from your mean, that will be an outlier, and the same thing, anything that lies below 3 sigma from the median also is an outlier. But for applying the Tukey criteria, you don't have to know anything about the distribution of your data. Your data can obey any type of this statistical distribution. Okay, and what type of plots we can do when we're trying to do an exploratory data analysis? Well, we can do histograms to summarize the distribution of data. We can do box plot, which tells you how your data is distributed, and also in the box plot, you know where's the median and where are the quartiles. You can do a cumulative distribution function to see what values are, how the values are distributed. You can do a quantile plot or scatter plots. And in Python, you have different ways of doing your exploratory data analysis, Pandas comes with a basic number of functions where you can compare data frames, you can compute the correlation between the values, you can do a general statistics description of your data. You can try to drop the rows that have missing values, or you can fill the missing values with some methods. You can ask information about your shape of your data frame, etc. And then you can continue combining different data frames using this merge, join, or concatenate data frames in order to have an integrated data frame. Okay, then there is a new, say, trend in Python, which is the low-code libraries. For the exploratory data analysis, there is a list of them. We have the pandas profiling, the sweet bees, the auto bees, the data prep, the looks API, and the data prep, and some others. This change is very fast. We are going to go back to this, but let me just complete the whole overview. So we can do our exploratory data analysis using Seaborn, the visualization library. We can do scatter plots. We can do light plots if we're trying to study if there is a relationship within the data. Or we can study the distribution using histogram plots or kernel density estimate plots. Or we can plot for the categorical values. Categorical values variables are like when you're having gender or day of the week. So those are categorical plots. So you can do a strip plot, a swarm plot, box plot, violin plot. We will see some examples of them. And then we can do regression plots, can do heat maps for matrix plots, and also we can do multi-grid plots. So these are Seaborn. Seaborn, as we have mentioned, is easier to use than Matplotlib. It is based on Matplotlib, and also Seaborn allows you to have a combination of Matplotlib commands and Seaborn in order to produce some plot that satisfy your requirements. Okay. And then I have a couple of examples. I'm going to use the second example just to show what is a formal exploratory data analysis using Seaborn and Pandas all the way. And then I'm not going to focus on how we are producing the different plots, but just to show you what type of products you can produce. So let me go in to this notebook. I'm going to post this in the chat. So and this is an example. I won't try to run it. So whoops, let me go back. Okay. So just I'm going to give you a general description of what this Jupyter Notebook does. So we need to install some pre-required libraries like the Python multipart, the Ubicorn, Kaleido, Fast API, PyWalker. And then this is a requirement because if I run it in Google Colab, they are not installed. And then I import just the standard Python libraries, numerical Python, Matplotlib, PyPlot, Seaborn, Pandas, and PyWalker. And then we're going to analyze the white and red wines quality. So there is a data set, and there is a data set for white wines and a data set for red wines. So I just read them using Pandas read CSV. And then just want to know how the white wine data set is formed. So we have several columns with different chemical properties of the wines. And then at the last column has to do with some quality. So the wines are classified in 6 qualities. And then the red wine is similar, they have the same number of variables. And then these are the physical properties of the wines: the fixed acidity, the citric acid, volatile acidity, residual sugar, sulfur, chlorides. And then what I will do is just combine both data frames into a single one. So, well, first of all, I just have to create a new column for each wine type. So all the elements of the white wine will be having a column added with white. And the red wine data set, I'm going to add a column type red. So the white wine has 48,098 entries. The red wine has 1,599 entries. And then I'm going to concatenate both data frames to create a single one that has both red and white wines. So the new data frame, which is called wines_df, will have 6,497 entries. And so I combine the two data frames. Then I can try creating the first histograms. So I'm going to use the pandas group by function and combine quality and type. And then going to make, I'm going to skip the PyWalker. So I'm going to start creating plots. So the first plot is the distribution of the red and white wines. I'm going to use Seaborn. So these are just the definition of different parameters for our plot: fonts and the figure size, labels, the general label, the label for the X and Y axis, and we're going to use a grid. Then I'm going to use count plot from Seaborn to produce this type of plot. So now I have the different wines by quality and also depending if they are white or red. So this is the distribution of wine quality and color. And you can see that there are a couple of wines which are very low quality and some wines which have highest quality of 9. Then we can try to detect if there are some outliers using the 2-case criteria. Everything below 1.5 times the interquartile range below the first quartile will be an outlier, and everything above 1.5 times the interquartile range over the third quartile will be an outlier. And that's the idea. And then we just apply this criteria. Everything that is lower, we will find the lower outliers, and everything that is above the third quartile, above the interquartile range. So we will find that there is 49 outliers applied on the fixed acidity. On the volatile acidity, we will find there are 19 outliers. On the citric acid will be 1 outlier, residual sugar 155 outliers, and so on. And then we can try to make plots. So we will try, let's see. Okay, so we make box plots for the different wines. And we will see that for the different variables, we see how the data set is distributed or the property distributed. Everything above this will be just outliers. And you can see that some of the data is compressed enough, so we cannot notice any details. So we need to change the y-axis into a logarithmic table. So now we can have a better overview of what is the data set about. So we have, again, the same physical chemical properties of the wines, and these are the values, but now I'm using a logarithmic scale. And I produced a box plot using Seaborn. Okay, we can produce bar plots. So this is the the bar plot grouping quality, um, and also for each variable. So I have a bar plot for every quality on the different properties. The idea when doing this exploratory data analysis is try to answer a question. Whenever you have a data set, you must have some question about the data set, and then you try to answer that question. So the question in the cases of the red and white wines is what makes a good wine? What property is the one that produces uh, the quality of wines? So we are just doing different types of plots. We can do these bar plots. We can do these stacked plots where we have by quality, we have all the different contributions of each property on the wines. So you can see, for example, the darkest blue is alcohol. Then you have pH, this lighter blue. You have the fixed acidity in red, and in orange you have the citric acid. In yellow you have the free sulfur dioxide. So this is the composition of the different wines by quality, and you can see the relevance of each property. Then instead of having 8 quality wines, we will reduce into 3 categories. So we rearrange all the data into 3 categories. This is the piece of code that arranges your data into 3 categories, and then we will just have this plot. So that's what we mean by doing exploratory data analysis. You're trying to extract information, you're trying to answer some question about your data set, and you're using heavily your besides pandas to extract information and organize your data. Also, you're using Seaborn to produce different plots trying to answer. In this case, we're going to be using a Seaborn scatter plot of the citric acid versus the alcohol as a percentage in volume, and see what makes a good quality wine or a terrible quality wine, and trying to extract some information so we can try to do relational plots, and we can do, for example, this scatter plot again with Seaborn, and and we can use different sizes for the amount of alcohol. We can use different colors for plotting the different qualities of wines. So in this case, although we have a two-dimensional plot, which is residual sugar versus alcohol, we are using a size of the dot to denote the alcohol content, and also we're using the colors to separate the different types of the 3 classes of wines. So this is actually a 4-dimensional plot of 4 dimensions. We can do correlation heat maps, trying to find if there is a correlation between the different variables. So this is with the help of a heat map from Seaborn. And also, since the correlation matrix is symmetric along the diagonal, then we only need to print the lower triangular matrix in order to see if there is a correlation. We have a table of correlation. The lighter the color, the more, I mean, in green, it will indicate the more correlation between some variables. So there is some high correlation between the citric acid and the fixed acidity. There is an anti-correlation of pH versus the fixed acidity. The more acid something is, the less pH it has, etc. Then we can do correlation between the compounds, the same thing, I think. Okay, and then we can do average chemical distribution across a high quality red and white wines. So we're trying to see what influences wine to have high quality. And we will find that that there is a high correlation, or something that is a wine that is a high quality will have a very high content of alcohol, for example. Okay, so that's the example using the wine data set. There's another example of using the Titanic passenger list. I'm not going to go into the detail. I'm going to go back into our notes and the next thing I will do is try to do a low code, no code libraries. So you saw that the amount of work you need to do when you're trying to do exploratory data analysis by hand, let's say. But there's all this new set of libraries that not a large amount of coding is needed to do the exploratory data analysis. So let's select these other nodes. I'm going to post this in this chat. And please tell me if you are following the discussion or I need to wait. Okay. So this is the new other set of nodes. So we're going to introduce, we already know what is the exploratory data analysis, but we're going to discuss these new libraries. And these are the most recent ones that we're going to try, and also we will show you how to use them. I'm not going to probably exhaust all the list, but I'll show you at least the first three how to do it. So there is a Jupyter notebook with these notes. I'm going to post that in your chat. And then this notebook I will try to replicate, and I ask you to do the same. So when you get into this Jupyter notebook, try to open it in Colab. Oh, come on. Got lost, sorry. Okay, did I copy it? No. Okay, this is the notebook. Okay, this is the notebook. So we open it in Colab. And since these are very new libraries, uh, probably they will not be installed in our Google Colab session. So I need to do some installations. So the first library I'm going to try is the white data profiling, and this is the documentation page, and you can see that now what version we have. Not exactly. I don't know what version is, but anyway. Okay, so let's start installing all the prerequisites. We need to install visions. So we do, well, actually, it's commented. I don't need that. So I'm going to use the exclamation pip install. It's a command to the operating system of your Google Colab instance, and it's going to install using pip the library OpenAI, and I'm going to install in a quiet mode so I don't get all the feedback. Okay, yes. So it's going to be installing. Hopefully everything goes well. The next thing I need to install is this TikTok library. Has nothing to do with TikTok. It's just a tokenizer library. And so I install it. And then if it doesn't complain, I install the next one, which is Cohere. Okay, about to finish. Then I should install the Fast App API or Fast API. How do you know what we need to install? Well, whenever you try to run something and it complains that it's not installed, then that's a hint. And then you try to install in a order fashion. There is required. Some libraries are required to be installed first, others later. The same thing for Ubicore, Kaleido. How do I know I have to install this? Well, the first time I tried, it complained, so I tried to fix and the installations in the specific order it demanded collab. This Jupyter notebook may not work well in 6 months or in 3 months ahead because maybe some new library is required by some other that needs to be installed. So, okay. So now we have covered all the prerequisites. Now we're going to install these system requirements for doing for showing the results of the pandas profiling inside the Jupyter notebook inside Colab. Okay, so it's doing that. Okay, so it's executing and installing. And should be finished. Okay, so now we have installed everything to start. So now we import the basic Python libraries, NumPy, pandas, and then I'm going to install profile report from Y-Data Profiling, which is just the one we installed. And we're going to be using the famous penguins data set that everyone knows. This is just the first info. We need to eliminate the missing values data rows. And also we can do a describe of the statistical numerical properties. And then we can do a profile. So I'm going to define a variable which is called profile coming from the profile report of the data frame using this title profile report. Done. Then I'm going to convert the report into widgets in order to show it on Google Colab, Jupyter Notebook. So now it's transforming the report into widgets. That means visuals objects doing the conversion, rendering, and we should have uh, the output of the profile report of pandas profiling inside the Jupyter Notebook inside Google Colab. And so basically, once I have read the data file and had made all the different installations, I'm just going to run two lines of code, the profile, this one, and also converting the profile to widgets. And now I have the results of the pandas profile. So it looks like a file with different tabs. So the overview, I have 7 variables, number of the observation 334. I have 3 categorical variables, the species, the island, the gender, and numerical. I have 4, like the flipper length, the flipper culminant depth, and weight, and others. So these are the variables. So these are the species. So I have 3 distinct values. This is a correlation. This is a categorical variable. So I can see the different variables, the island. This is the island. And then I can do by sex or gender. This is the plot for the gender. And our data set has this property that one line of one line of the data set has a for gender has a dot instead of being male or female. So it tells me in my data exploratory analysis that I have three variables or three outputs for the gender sex. I can do the same thing for the Pullman lab. Yes, right.
So all of this was done after the import and it pulled that from the headers. Is that what I understand?
All that was done by just running two lines of code, profile,
Wow.
profile report, and profile to widgets. And this is the widget. So this is the visualization of the profile report. Remember we
This is
had
even better than pandas.
no, yes.
Cool. Yeah.
The idea is that once we have installed all these different instructions for the Jupyter notebook inside Google Colab to display these special graphics or plot, then we only had to run two lines of code. Of course, we have to do 20 installations, but once you have your two lines of code, you have these results. So you have a visual of what is the distribution of the Kuhlmann length, how many distinct values, what's the minimum, what's the maximum, what's the median, what is the median, should be here. What's the, yes, so you have all the different relations and values, how many zeros you have, how many missing values, but since we use the drop NA, we don't have any missing values. Maybe we can try directly without doing that. Okay, and so I can do the same thing with all the numerical variables, right? Just for illustration, I'm going to reread the penguins data set, and I'm not going to drop anything, okay? And I'm going to produce the new profile and display the new widget, okay? So I just have the raw penguins data set, this realization of the penguins data set with missing values and having three values for the gender. Can you export to HTML? Yes, you can. The next case, we will see how to get an HTML directly. The next library will have a direct HTML. Okay, so we are reproducing again our data set. And what happened? Still ready? What? Did I run out of time? Yes. Yes. What? Oh, come on. It broke. Uh, okay, so this is the profile report in HTML. I should have it here. No. So I'm overview. See, close this. So this is the overview. Again, 7 variables, number of observation, number of missing values, missing cells, duplicate rows, categorical, numerical, and also if there is a correlation, you have to select what you want to see. And then you can select like body mass, the distribution, how many distinct values, what's the minimum, the maximum, the zeros, mean, and then you can have more details. So it has all the statistics, Q1, Q3, the 95% percentile, the 5% percentile, the interquartile range, all the different moments, standard deviation, the kurtosis, the mean, the skewness, the sum. So everything about you wanted to know about the statistics of a numerical variable, you have this histogram. If you want to save this, probably what you can do is, since this is a Jupyter Lab, Control Shift, no, Control, uh, what? To save the file, to save the image. No, it's not working. There is a way of saving an image. Let's see. What's the shift command? Well, I have, well, anyway. And then common values, extreme values, everything you wanted to know about your file is there. Then what are the correlations? This is the interactions. What's the correlation between the Kuhlmann length and body mass? You have a scatter plot. Or if you want to do the Kuhlmann length versus the Kuhlmann depth, this is the correlation. And then autocorrelations. So that's you have the heat map, and you can see the correlation matrix. Missing values for every variable, the matrix of missing values, and a heat map of missing values. And then you have a sample of your data set. So everything was done with 2 lines of code using pandas profiling for the penguins data set. Okay. So that's what I mean by low code, no code. Just two lines of code, and you have all the possible things you wanted to know about your data set. Okay. Any questions? Is there a hand raised, or was it before? Okay. If there are no questions, let's go to the next library. The next library I want to show you is the SweetBees. So I'm going to install SweetBees using pip command. Once I have installed it, then I will just import SweetBees as SB, and I'm going to select my data frame will be just the penguins data set, and then I'm going to analyze the data frame and then show the HTML. So after you import and you have defined your data, you only need 2 lines of code to produce the analysis. So let's do it. So it's analyzing the data and producing the report. And we are going to see, we have now an HTML file from this SweetBees. And then this is the SweetBees report. It's a visual sweet visualization. So we have the different variables, species, island. You have for the categorical variables, species, island, and you have the bar plots. And for the Kuhlmann length, Kuhlmann depth, and Ripper length and body mass, which are numerical variables, you have all the histogram, frequency histogram. You have all the different information of how many values are missing, how many are different. And then what is the maximum, the minimum, the median, the average, the first quartile, third quartile, the 95% quartile, the range, the interquartile range, standard deviation, variance, kurtosis, skewness, sum. So you have all the statistical information about the numerical variables with only 2 lines of code. And it's done for this, the same thing is done for all the numerical variables. So this is the output of the sweet visualization. Okay. And this is what we had with the previous, the pandas profiling. Okay. Any questions? Okay. So you get the idea, right? The third option will be, is this working for you? Are you running the installations? Somebody has a problem with that? Yep, okay. Okay, so let's try the third option, which is the Lux API. So we install it. Quiet. Less information coming back. How to change the default plots with different parameters. It comes with the specific parameter ranges. Maybe that's done dynamically because you can read different data frames. Yes, and it will have some definition how to change the range, like the minimum, the maximum, and probably if you read the documentation, there must be more ways of changing the default parameters. Um, I don't know. You have to, like, arranging multiple plots in a single image. That's additional. So you can do it by hand using multi-grid or seaborn scatter plots. But not from this. This is just the standard output. This is the basic info, and he was trying to cover all the information from a specific data set and or data frame, and then this is the standard output. But it gives you the basic information to go ahead and continue exploring. So okay, so I installed the Lux API. I'm going to install this Jupyter Notebook extension widgets. Okay, and then I'm going to import Lux, import pandas, and import this Google Colab output and this command for widget manager. So I execute. So just import the libraries. I'm going to read the data frame, but I'm not going to drop the empty missing values rows. And then, so now I execute this. So I only have defined the data frame. And since I have already loaded the Lux API, when I have, when I, when I say print the data frame, I can toggle between the output of the pandas and the output of Lux. So I just select that. So I can just switch back and forth between the data frame and the visualization of Lux. Shows me correlation between the numerical variables. And I can see the distribution for the numerical variables. I can see if I select one of those, should show me something. No. Okay. The occurrence, okay, so this is a frequency for the categorical variables and correlation, just the scatter plots. Okay, so this is the output of the Lux API, and you toggle between the pandas data frame and the Lux output. You have basic information about the distribution, the correlation, and the occurrence of the categorical variables. And okay, so now we have use three types of low code, no code exploratory data analysis. We may have time for the last example, the data prep. So I'm going to install it. Hope it works. I haven't tried this in a couple of months, so it may have changed, maybe not. Okay, so it's installing, and yeah, if it fails, Okay, and I think it's gonna fail. Yes. Error. Okay. Something has changed since the last time. So it's requiring specific library numbers for the SQL Alchemy. It's requiring something equal to 1.4, but I have the SQL Alchemy 1.3, which is incompatible. Then if I try to install this, probably something else will be in conflict. So my best recommendation is just to give it this up and try a different um, library. Okay, let's see if the AutoBees example runs. So let me install it. Unless you really want some library and try to make it work, then you have to you know how what to do. You just have to have a clean install and install all the requirements for the different versions of libraries. And if you're talking about reproducibility and you have written a piece of code and then somebody else tries to run it 6 months from now or 2 years from now, you will probably have different conflicts. So you have to specify all the different libraries you have used in order to reproduce, or just create a container like a Docker container with just the specific libraries that made your code run. So anyone else can just take that container and make it run. Okay, so I have another dependency error. So it's complain about Pydantic. Okay, so let's see if it works, even if I have an error. Yes, I can read the penguins. Yes, okay, it worked. So I just loaded the AutoBees library and define my data set and then applied AB AutoBees to my data set, and I have the results. I have the scatter matrix. Let me go up. So I have the data frame and tells me what type of data my columns have or my variables have, how many missing values, how unique number of unique values, the minimum, maximum, and how many missing values, and then shows me how to impute or how to replace the missing values. Then produces the pairwise scatter plot of the continuous numerical variables. And then couldn't draw the distribution plot, but I have violin plots of all the continuous variables. I have the heat map for the correlation between the different variables, right? And I have the box plot for the different categorical variables, for the Kuhlmann length, for defined by species, uh, Kuhlmann depth by species, flipper length by species, body mass by species, and different plots. And then, okay, so that's about all the results I get, right? Yeah, I'm just viewing the whole data set, 367 values. Okay, so now you have an example. You just need to plug your data frame, data set, and you can try all these different libraries. We saw that data prep was the only one that didn't run because I created this a while back ago, but now it's not working. But the other ones do. So, okay, so that's what we mean by low code exploratory data tools. And you can find different, let's go back. Oh, Okay, so we're in data science. Yeah. So this was what we call exploratory data analysis, and you know that there's a lot of work you can have to do by hand trying to extract information, but you can find this set of low-code exploratory data analysis libraries that only requires after you install all the requirements to run like 2 or 3 lines of code, and then you get the whole overview of how your data, what are the main characteristics of your data. Okay, so it's too much information, I know, but sorry, that's what I got.